I'm going to start by talking about some very well-known correlations that are out there, also with probably some lesser well-known correlations. Let me know which ones you find surprising. Money and happiness, depression and self-esteem, cartoons and your height, ice cream sales and number of reported drowning incidents, Nicolas Cage movies and Googling zombies, drinking wine, health, coffee and memory, books and IQ. So I bet some of these sounded very, very logical, hindsight bias. And you were like, well, yeah, of course, yeah, sure, that makes sense. And then there were a few others that I mentioned in there that I'm sure you were not expecting are correlated. And that's because you're already getting stuck in the first trap of correlation. That correlation is not causation under any circumstances. Meaning that while already you were like books and IQ, yeah, of course, that makes sense. The more books I read, the smarter I'll be. But when I said Nicolas Cage and zombies or cartoons and your height, I bet you were like, wait, how is that? How are those two things related to each other? How are ice cream sales related to reported drowning incidents? And that's because you're getting stuck thinking that correlation is causation. And it's not. It's not. It can't be. It will never be. And you need to get it out of your head. There's only one test that we can do that can assume cause and effect relationship, and that's an experiment. That's it. A correlation is the measure of two variables and the extent to which one can reliably predict another. That's it. Just how they are related. Yeah, okay. I can tell you for sure Nicolas Cage movies and Googling the word zombies are correlated. Does that mean that one's causing the other? I guess that depends on your opinion of Nicolas Cage. But let's talk about ice cream sales and the number of reported drowning incidents every year. So I'm sure that's usually the one that surprises people the most. But if I graph it out for you, and we're going to graph all of our correlations on what's called a scatter plot. So I'm going to graph it out for you. And this is always zero, remember. And up here, I could put ice cream sales. And down here, I'm going to put drowning. A really happy topic for the day. What time of year do you expect ice cream sales to start to go up? And what time of year are people most often swimming? So perhaps the season has something to do, some outside variable has something to do with this relationship here. So, or maybe even temperature. I can tell you reliably for sure that if ice cream sales are high, drowning incidences are also high. And I could plot these two out and put that right about here. And as ice drowning incidences are low, I can guarantee you that ice cream sales are also low. So I could probably plot that about here. And we can for sure, it's not going to look just like this, but we can for sure assume that this would be how that relationship looks. And if I could take an average of all those dots, it might look something like that. Much straighter line than what I just did. And it's not because one is causing the other. If I want to decrease drowning incidences in the United States, I wouldn't cancel all sales of ice cream, right? We can't say that one is causing the other, but we know that they are related somehow. And in this case, they're related positively. As one goes up, the other goes up. This is called a positive correlation. Now let's take one of the other examples that I gave you. We're going to plot out another one on another scatter plot. So here's my x-axis and my y-axis. There we go. We got 0 right there. Let's look at depression and self-esteem. Assuming that that's 0 and that's really high and then that's really low, if somebody's depression is really, really high, where do you expect their self-esteem to be? Really low, right? So if their self-esteem will be way down here and their depression is way up here, so we could plot that right about here. And what about if their self-esteem is really high? Where do you think their depression is? About, on average, probably really low. And we can plot that all the way out here. And we can imagine it's not going to be just like this, but we can imagine all the other points are probably going to move in this direction in between. And if I could take an average of all those dots, it's going to look something like that. And when the correlation is going in this direction, looks like from the left to right, looks like it's going downwards. This is a negative correlation. Why then is this an inferential statistic? Well, because I in the definition of a correlation, I said, and can reliably predict the other. That's where it is. So if I have somebody whose self-esteem score is somewhere, if I have someone whose self-esteem score is somewhere around here, I can predict that their depression is somewhere about here. And that's where that can lead. I know in the future, as ice cream sales start driving up, I can reliably predict that instances of drowning are also going to go up. That is a really morbid thing for me to talk about. Let's do cartoons and height, because that's also a fun one. How are these related? I imagine that when you were really short, you were watching a lot of cartoons, so it'd probably be about here. And as you start to get taller, the amount of cartoons you're watching is probably lessening. So it's about here. Cartoons will never be zero because, let's face it, you're human and cartoons are amazing. But definitely less when they were when you were a baby or when you were a toddler. So that's also a negative correlation. And I can reliably predict that for other people. We measure correlation with what's called a correlation coefficient. And for our purposes, we're going to use one specific correlation coefficient, and it's called Pearson's R. Pearson's R can be measured in between a score of positive 1.00 all the way to a negative 1.00. And 0 will be somewhere in the middle. 0 representing no correlation. That's when all of your scatter plot is just like a big blob of points with no way for us to really draw an average in between it. So the stronger that your score is to either -1 or +1, the stronger your correlation is. And I need you to remember that because so many times, so many of my students get tripped up on the test where it's like, please identify the strongest correlation in this group. And it'll be like, 0.65, 0.32, -0.78, and 0.15. And my students so often are going to say it's this one, and it's not, because 0.78 is closer to a -1, which means that -0.78 is still a stronger correlation. Negative correlation doesn't mean less of a correlation. It just means that it is related in the negative way. When one goes up, the other one's going down. And a positive correlation, when one goes up, the other one also goes up. So they sort of like mirror each other. But a negative correlation is when they relate inversely. All right, that's correlations. I will see you in the next video, and we're going to recall some of the stuff that we already discussed in prior lessons. See you there.